Go
I just wanted to
ahead.
make sure, like, yeah. Well, yeah, this is going to be super dumb, but yeah, I actually don't know how to do this.
It's okay. I don't use a ton of Zoom either. So it should just be down at the bottom. You'll have the option to share your screen because I did enable it for you.
Oh yeah, there we go. Okay, share screen, and let me see if I can get it to just get. Okay. Okay, so I guess you see just this part of my screen, right? Like just the window.
Yeah, so we can see your window, and then there's just like a tiny version of you off to the side.
Okay, yeah, that works. Okay, so I move that away. Okay, all right, yeah, I guess we can get started then. So yeah, so hey all for joining this talk. I'm Sarma. I've been working as a software engineer for close to like 7 years now. Mostly as a backend and a machine learning engineer. And I have experience with just basically a lot of backend programming and also putting ML models into production. So yeah, I guess for today we can just get started on this talk about GraphQL. So for the talk, I was initially trying to figure out if I should do sort of like a live demo where I edit code, but then I figured there's actually a bunch of good playgrounds out there that I can just use to sort of like go over concepts and look at some code that somebody else had written, which is a fairly small pie project, and we can just go over all of the concepts there. So yeah, I guess we can get started now. So before we jump into GraphQL itself, like initially, I think before I signed on for this project, it seemed like you guys would be using Gin for the backend code, but it was changed to GraphQL. So I had initially provided this framework slide, but I wasn't sure if this was useful or not, but I thought I'll just quickly go over it anyway. I think in general, if you're trying to learn something new, and this applies to me as well, like a framework is usually well designed, and they have a set of operating characteristics that we can use. And GraphQL is no exception. But for the most part, frameworks tend to have either a specification defined or they use a specification and then they implement that. So I just wanted to like just highlight this fact that all of the implementation, all of the client and server code that you would see or you would write is very well defined, and you yourself can go read what was done. And I think for GraphQL, the release basically the release spec that they use is nicely written, and it's a good experience to go read it. And I think in general, most frameworks tend to fall under either they're like super lightweight, like Flask if you've used Python, or they're like sort of here's all the functionality we get out of the way. You can do whatever you want, however you want, or something like Django or Drop Wizard, which is super opinionated in how you do things. So they have very specific conventions on how to do certain things. So for example, if you're writing like a URL, like a route for a web API that you're creating, Drop Wizard has a very specific way of doing it. Flask doesn't really care, for example. So yeah, I think for GraphQL, the framework itself is it's sort of dependent on the implementation. So the spec itself is very lightweight, but the actual implementation varies. So for example, I think you guys are going to use Apollo. So I think that's the most commonly used or most widely used implementation for GraphQL. So that has its own set of quirks versus something like Hasura, which is also a very popular GraphQL framework, but that's tied to basically Postgres. They have like certain additional features that you don't actually find in GraphQL that makes it easier to do certain things. So I guess, so what is GraphQL, right? I guess like as an intro, I would probably say GraphQL has those 4 bullet points on my slide as its main characteristics. So the first one is it is a declarative query language that you can use to interact with user APIs. So I'll get to explaining all these terms in a second. But just like sort of declarative query language just means something like SQL. That's a reasonable thing to hold in mind. The second sort of asset is the fact that GraphQL has a very heavy server-side runtime environment that you as a developer are responsible for, and also have to write some code there that helps you or facilitates writing or executing the queries. And then there's also a type system that helps define the queries and your data. So GraphQL also has this concept of here's a way to interact with APIs, but here's also a way to describe the data that you're working with. And finally, the most important point about GraphQL is that it is a implementation that is fairly agnostic to the database, or I should say it is agnostic to the database or the storage that you use. So as long as the database that you care about has some sort of an implementation for GraphQL, you can use it, but GraphQL itself doesn't really say, I want to use, I don't know, Postgres versus MySQL versus DynamoDB or something like that. And yeah, like I said for the first slide, you can go have a look at spec.graphql.org with the reference implementation that's there. It's very nicely done, and you can learn a lot just by trying to read that. Okay, so what is GraphQL in terms of like breaking down those like 4 facets that I wrote up? So declarative query language. So like I said, if you think about SQL, that is also a declarative query language. Basically, what that says is when you. So I'm not sure if you guys have a lot of experience with SQL, but if I had to just explain what declarative means, it is just that to do something, you have to know what you want to do and how you have to do it, right? So for example, if I asked you to write a curl command to query, let's say, I don't know, Twitter's API, and you're developing some sort of an application, so you know exactly what to do. You go and say like curl, and then you put the headers, and then you write the API, and then you prepare the request, and then you get back the response. So when you do that, you're using curl as an application that is under the hood doing all the stuff that it does for talking to Twitter's API over the network. The act of using that interface is what a declarative action is, because you're just saying, well, okay, so here's some input, give me the output. I don't really care how you do it. For curl, you can kind of like modify those things a little bit, like you can change timeouts and things like that. But for the most part, if you just said curl this, curl will give you an output. It's the same thing with SQL, right? If you do select star from table, you're basically saying, I don't care how, or like what kind of indexes you use, how you store the database, how you store your data in the database, or like do you have failover, do you have like replication, all those things. So just like the SQL language just says, if you ask me to do select star, I'll just give that to the database, and the database will take care of figuring out whatever it needs to figure out to get that data back. So from SQL's and GraphQL's perspective, all that they want you to do is just say, I want this, and then assuming you have all the pieces put together, you will get back the data as you expected. So user APIs, so to interact with user APIs, you need to also do a little bit of code, like that says use GraphQL.call client. So all of that is provided to you. But then as long as you have like a GraphQL server running with access to like database and things like that, you should be good to go. And server-side runtime just means that it's on the server side. Runtime specifically just means that, okay, on a remote box or on a local box, you have like Python or, whatever your GraphQL is, right? So it could be like Python GraphQL stack. So something like that is running. So that's all server-side runtime means. And type system. So I think in general, we all understand what types are, unless you've taken a compiler course and you understand the actual details of how type systems work. Like even I don't know a lot about how the internals work. But type system in general just means that whatever you're interacting with in terms of data is well defined. So for example, if you work with numbers, you always know that the code that you're dealing with is treating them as numbers or ints. There's no ambiguity there. So I think if you have worked with Python code, because that's like a very stark example. So Python 2 before type hints and all those things, you were just dealing with abstract objects. You were not actually dealing with types per se. When you run your code, the code obviously has a type, right? Like when you, let's say you write a Python server that takes in a request response and you're doing request response using JSON, obviously Python knows what that string is and how to interpret it. So if you wrote some code that says, take the JSON request and convert it to like an internal dictionary, right? So at that point in time, it knows what to do, but then the code actually doesn't care that you're dealing with that JSON object. So it's very easy to make mistakes and things like that. What GraphQL provides is a nice framework around saying, this is my data and this is the shape in terms of like types for my data. And I think in general, like types, at least in my experience, like Python in production, or basically it's only Python in production that I work with, has always led to a lot of bugs that could have been easily caught if we had like a nice type system that we could take advantage of. And I think I explained what agnostic means, so we can go over that. So one of the cool things about GraphQL is the fact that they put a lot of emphasis on modeling your data. So if you've done like just REST API design, there are certain sort of principles, right? Like you have those keywords of put, get, delete, etc. And you have some kind of semantic around them in the sense that if your API is a get API, you kind of know that, okay, you should get back data from that call. And let's say you have a put action, right? So for REST with a put action, you can reasonably assume that your data goes into a database and then presumably it gets saved as per like the understanding of put. But those are just the operative portions of REST and just general web design. General like API design. But we don't usually think about the types themselves. So let's say we are dealing with this data set that is geospatial. It has a list of countries, a list of continents, and some sort of attributes associated with them. So for example, continent is like Asia or something, and then you have within Asia, you have a bunch of countries inside them. So if I were to ask you to like design this system, and if I just said, okay, this is a data set, or this is a database, and you have this task of designing an API that can get useful information out of it, how would you go about like trying to think about things? So usually, let's say we just stick to relational databases. So something like MySQL, right? So if we go with that approach, what we generally do is we'll say something like, we have continent with code and name. So I'm just like, these attributes don't really matter, but I'm just going with a couple of them. So let's say you had continent, it has code and name, and then you have this other object called country that also has like its own code, its own name, maybe some other fields that we don't really care about, and then there's a continent code. So usually with SQL databases and relational design, what we do is we have this continent code associated with every country, and this continent code has to map back to one of the codes in the continent object. So by drawing this arrow and writing these fields out in a relational design, we have two tables. one for continent and one for country, and then you have a foreign key that helps you map them. And in this process, you sort of develop a one-to-n relationship where one continent can have multiple entries associated to it in this country table. And we can repeat the process. Country can boil down to provinces or state, and the same thing sort of happens where you have like this foreign key that you use to map objects and then map the relationships. But I guess this is the key innovation that GraphQL introduced and had due to certain other reasons that were there when they were developing this software. So with GraphQL, they're making the claim that a more intuitive representation is something like this, which is a graph, or it looks like a graph, right? It's kind of like a DAG or a tree, maybe, which just says, if you had the continent and country relationship, instead of thinking about them in terms of tables, why not, maybe think about them in terms of these arrows with associations on them. So GraphQL basically provides that kind of modeling and the tools to support such modeling. So I'll come back to explaining all of these terms and how all of this works. But for now, you can think of this picture here that says you have this one node for country, one node and several nodes for, one node for continent, several nodes for country. Each of those you could represent as like these objects. And the way you link them is through this countries field over here. So very similar to what the relational table would have done, except instead of having kind of like a flat structure where you have like one table for continents and one table for like the countries, you have like these little blobs that are sitting around, these blob objects, which is kind of like a JSON dictionary at this point, that has like all of this information. And then if you looked at any one blob, you kind of know how to get to some other blob because of the relationship that's being established. So this country and this country sort of line up. And if you were to like plot your data out as a graph, you would kind of know what to do with it in terms of like following the arrows. Okay, so I guess just to sort of drive home the point, I wanted to like just state again that the key part or the key innovation for GraphQL was the graph aspect of modeling things. There's also other stuff around how the like backend agnostic part works and how this whole system operates. But really the key point is this. So any program that you write in general is basically a graph. If you think about it as a graph of execution, and I'm not even thinking about like what a compiler would do in terms of taking high-level code, moving it down to low-level code, and then modeling it. Even like this, I got this off the internet, and I can send you the link for all these pictures. I have a bunch more, but yeah, basically even this code that looks like, I guess it's like C++ or C code, you could potentially map it into this kind of like a control sequence that just says, okay, at the top, which is like node 1 over here, like if X is less than 50, you go in this like loop and then you do stuff, and otherwise you come outside. This is not very different from how microservices work. The only difference is like, let's say, at node number 2, you're doing if array of X, I guess this is like mod 2 equals 0. You could still do the same thing with microservices, except instead of running that line of code in your local machine or in that machine that you're running in prod, for example, you could basically have this other service that says compute mod 2, and then it only takes in one input, which is X, and then you can like build a whole HTTP server with like with the web API, with JSON and all that. So so in this example, yeah, basically, let's say if you worked at Amazon or something like that, this is very familiar, right? Like, so you had an e-commerce service that if a user comes in and wants to buy something, the e-commerce service will go call inventory, and then inventory will go make multiple other calls. All of this could have been done in one machine, in one like loop, where you just like look up stuff in within the same machine instead of making calls over the network. So GraphQL is centered around this view that data and your execution can be viewed as a graph. And this representation gives you like a better view of your domain. And I think in general, that makes a lot of sense. Even to me, it makes a lot of sense that if you try to force yourself to think this way, maybe it does a better job of modeling your business use case. Or at least it like kind of forces you to think twice. I think it makes a lot of sense because it's also very intuitive that we think about relationships rather like relationships as arrows or like causal arrows, as opposed to just being like these flat tables with links. So I'll go over like what all of these things mean, like the specific syntax and the specific outputs. But yeah, basically, if you can ignore the pseudocode for a second, or ignore this as pseudocode for a second, get all countries in the previous example would basically just say something like, I actually don't care if you have to, you meaning the backend server has to make multiple calls or one call or whatever it is. Assuming all the pieces are put together, get all countries as a query just cares that I want my continent data, assuming I pass in an input called code, which is continent code. Just give me all the names. Just give me the name of that continent and then all the names of the countries within that continent. It doesn't actually, like, if you looked at this code, which is what GraphQL's like client side will look like, it doesn't actually care about the fact that you're making a remote call or you're not making a remote call. Your data is in a database or not in a database. None of that. This is just like, this is all I care about. The wiring is kind of separate, right? Like there's additional code that you pass this query into that kind of knows where the GraphQL server is, but that's about it. No other issues, and a lot of the heavy lifting around making these requests and like passing data back and forth is taken care of by the framework. Okay, so I guess to solidify the picture again, in general, we deal with REST APIs for the most part in like regular software engineering. I mean, there are other types of RPC, but for now, if I were to just stick to REST API and try to like compare it with GraphQL to give you a better sense of mental model, I think this picture, like again, this was taken off the internet. I didn't draw this, but if you were to like, let's say, design a system that had players, teams, and matches, basically routes, doesn't really matter what those routes are. What you would do is you would build a web server with your code that knows what to do when a request comes in for players. Like maybe it reads this database and then it reads another database. It doesn't really matter. But the point is, to perform a REST API call in this architecture, you would have a client that knows players exist, makes a call. Maybe it wants team information, makes a call. And then the client code would take those 2 bits of information. And I don't mean bits as in small, I just mean, two giant objects of data, and somehow massages them as required and then shows it up in the client's view. So whether it's a mobile app or a website, doesn't really matter. But all of that client code will call these APIs, fetch data, massage them somehow, and then like show it up to the user on the view. GraphQL, aside from all the modeling and all the pieces that we just discussed, what it does is it basically abstracts this like middle part, and it just says, like the client doesn't have to make an individual call to each API like over here. GraphQL just wants you to make one call to the GraphQL server, and then GraphQL will understand that, okay, this is how so when somebody asks me for player, this is how I know what to do, and then I go fetch it. So I guess like from a general software perspective, this is a very interesting thing, because I think when you talk to people who have used GraphQL or know or generally understand what's happening, they will make this argument that GraphQL is kind of like too much, or like you don't need it for your use case or for your company or your business. I think in general those types of trade-offs exist, and that makes a lot of sense. But for now, like for example, you as a software engineer could have potentially invented GraphQL on its own, right? Like you may not have invented all of the pieces and exactly the same specification and all that, but you could have done something like, let's say you had a use case where you had to get player and team information from 2 different APIs. As a software engineer, you could have gone and written a new API that says player plus team information, right? And then it does all kinds of weird, or not weird, but basically all the stuff that the client needed it to do, and then return that information. So basically what you just did, what you could have done is move a bunch of client code and put it on the server, except now it's a little more messy in the sense that you had 2 APIs, two distinct APIs that potentially did a good job of representing your model. And now all of a sudden it's kind of like combined, and now you're calling it players plus teams. So now you have 3 APIs. It makes sense, but then in terms of like evolution and trying to think about, what about the next business use case or the next requirement that comes in, it becomes tricky. I'm not saying it is hard or not hard. I'm just saying like it makes it confusing because you did something without too much of a plan, and then it's unclear how to like evolve this whole system. So GraphQL is trying to say that I want to do exactly that, whatever I just told you about like moving some of the client code over to the server side. I want to do exactly that, but I have a very specific way of doing it. So that's basically what GraphQL is trying to do. So I think the mental model, if that helps, is to just understand that between code that used to happen on the client and the server, GraphQL is trying to say, let's move a bunch of it back to the server side, and then the client just cares about how to get data, the client just cares about what data to get and not how to get that data. Okay, so for GraphQL, the query language, we have 3 distinct terms. So we have types, mutations, and queries, and I'll go over them one by one. So what is a GraphQL type? This is very similar to the code that I just showed you a couple of slides ago. So basically, for any object that you want to represent, this can be player, this can be country, continent, all of those like basically complex objects, right? That have fields within them. You define them as a GraphQL object type with a name. And then with the specific syntax of the curly brackets, you put in a code name, temperature, and country. So in this specific example, you have 3 fields, the first 3, code, name, and temperature, that are scalar types. And I think this is very similar to other languages and how they think about types as well. So scalar, they are singular values. So ID is a very specific GraphQL syntax that just says this type is a unique identifier. You can think of this as a string, and I think internally GraphQL does string as well as a representation, but it just like ID just is a very specific or a quirky way of saying, this is an important field or a unique field rather. And name is again a string, and temperature is of type int. And the actual value that it could fall under, like whether it's a Fahrenheit or Celsius. This specific syntax just means temperature can take an optional argument that says like represent this value either as a Fahrenheit value or a Celsius value. So these 3 things are called field types, and I think this syntax is very similar to like Go. I think you guys are using that, so this should be very familiar. This bracket is just input, and this just means temperature takes in an argument called unit, and the unit type is temp enum. I'll go over enum in a second, but I think enum is fairly common that you might be able to understand what's happening here. And then finally, the actual relationships part, right? So if I had a type called continent, and I had to model the fact that a continent is comprised of multiple countries, you would do it this way. So let's call the field countries, which is a list of type country. And this operator, the bang operator, the exclamation just means that you have, like, every continent has to have a country, and it has, like, it's a non-nullable field. So this operator just says the type value is non-null. So if the server somehow returns a non-null value, there will be, some sort of a type check that throws an error and says, this is incorrect. So yeah, over here it just says countries is of type country, and you cannot have a null value here. So you will always have a country list. And the other thing to point out is you can have these types of arguments can have default values. So I guess the syntax might be very familiar. I think Go does the same thing, and lots of other languages do it. So this just says if the user decides to represent their data without it, pick up the default value. Give me a second. I think I accidentally got out of presentation mode. Okay. I think I jumped a bunch of slides. Okay. So the other important type is queries. So queries is a way of saying, like, get me the data. So over here, we have an example of a query that's called, so the query keyword is part of the syntax. You have here an example called get trips that basically says, give me an object that is called trip and pass in an argument called code to the backend server, and give me all of the passengers, the drivers, and the trip details from the data that you have. So basically, the syntax is just saying, if you had like a trips database and trips had, let's say, these 3 fields in addition to others, and you wanted to get the passenger details, the driver details, and the trip details, this is how you would write that query. So like, once I go over the syntax, I'll show you a live example of how all of this fits together. But for now, I'm just going over this so that you guys can have a good sense of what to look at for regular code. Okay, so the other thing is mutations. So just like in REST, you have delete operations or like put operations that change the data that is behind the server. GraphQL has this concept called mutation that basically mutates the data object. I guess the idea for calling in mutations is exactly that, like you're mutating a specific object. So very similar to the previous syntax, mutation is defined as, like you have this keyword mutation, and then you have the name for it, and then you have a specific syntax around how do you pass in, let's say, inputs. So this I guess is kind of like in JavaScript, where sorry, this part is in the query language, but like you have typed information about what the inputs are. So here it just has this $ID sign just says you have a placeholder variable that at runtime you would put in a value and execute the GraphQL query. So this is in GraphQL syntax. This is how you represent a variable of a particular type. So in this example, complete trip, you have 3. You have ID, which should probably be trip ID, as seen here, a passenger input data, and a driver input data. And tax is a data type very similar to this one. So over here, you have 3 non-null inputs. And then what you're asking GraphQL to do is call the complete trips mutation, which on the back end will map to some actual code that will take in these 3 inputs and do something with it. And on the client side, what you're asking for is make that mutation, and then give me the trip time as my output. Okay, so to quickly go over some of, I guess, the simpler portions of the documentation. Yeah, so GraphQL types are composed of primitives and composites, as with most other languages. So the primitive types are, you have ints, floats, strings, and booleans, and then the ID type that I told you about, which is serialized as a string. And what I mean by not read as one, it just means that like a UUID, for example, that you may have used is also a string, but you don't actually read it. Like you can't really read it as a human. So I think int, floats, and string, these are all fairly easy to understand. 32 bits, double float, and UTF-8, and Boolean. I think the specific value for Booleans are true or false. Okay. And the other important type that certain languages have and some don't is enums, which are super handy for modeling your business domain. So enums, I think Go has them. So enums are, like the familiar object, which is a fixed set of values that your variable can take if it's of type enum. Because GraphQL is kind of agnostic to the underlying language, the actual implementation of enum changes, but as you're writing client code, you don't really have to worry about what GraphQL does under the hood to support enums. And then I guess the other thing to talk about is type modifiers. So for GraphQL, there's just two main type modifiers. So one is the exclamation, the bang operator, and the list syntax. So I guess this kind of like depends on each language. So some languages have very clear ideas of what a list is or what a list is not. So for GraphQL, they actually don't consider, I guess they don't think about it as a top level type. They just say a list is a modification on an existing type. It just means that there is more than one value or one count of that type. So for example, like, yeah, instead of thinking list of country, you just say, you have multiple countries. I think that's a very interesting way to model the domain, because it gives you a clear idea that you're not dealing with a brand new data structure. So if you've used Python, Go, or Java, in all those languages, when they have list, they treat them as very specific abstract data types, which means they have operations like put and pop and those types of things. So I guess GraphQL is just making the nice distinction that a list is not an object by itself that you can manipulate. It's just that there are multiple objects. I think languages have different ways of calling this. So I think in Java and Python, they call it collection objects. And so for both these type modifiers, I think the other important distinction is that they are enforced as validation checks on the server side. So the specific difference is that there is code that goes and looks and says, if you pass in a null value for something that shouldn't be a null, this will raise a validation exception when you try to run your query. Okay, and the other important concept is interfaces. Again, very similar concept that you've probably seen before in other languages. So here, interface is basically a type that your other type or your concrete or implemented type has to adhere to. So for example, if I had this object called path, and I think I had a typo here. I think I, instead of calling this path and trip, I think I mixed up calling one of them the other. So let's just assume this was a typo and this was trip. So this interface trip has 3 fields: code, name, and route. and route is a list modified segment. And segment, again, is a concrete type. Again, we don't really worry about all the exact fields here. But for now, path is just composed of these three, and it's got a list. So if you had this interface and you wanted to implement a concrete type, let's say a driver trip, and just for clarity, like I'm just pulling these examples from working at Lyft, where we had similar ideas. So here, if you're trying to implement this interface trip here, and you wanted to have a concrete one called driver trip, you, as with other languages that you may have seen, you just do something like driver trip implements trip, and you have to make sure that the variables that the interface object has, so code name and route, has to map back to these variables over here. And on top of that, you can add other details. So for example, between driver trip and pax trip, which is passenger trip, these three fields are common, but this is different. So this guy is driver trips, which is a driver object. That's not null. This is pax details, which is a pax passenger object that is not null. So why are interfaces useful? From a data modeling perspective, let's say, so basically interfaces are and should be used to facilitate composition. I mean, enforcing behavior is one thing that you may have seen in Go through structs and things like that. But for interfaces for data, this example is of composition. So let's say you wanted to get, like let's say on here on the right. So let's say you have query get trip, right? So you want to get the trip details for a particular passenger. But you also know that trips can be of two types, passenger trips or driver trips. So instead of writing two functions that said, get trip for passenger, get trip for driver, you take advantage of the fact that there is an interface. So you abstract out the trip portion of things, and then you say, so get trip takes in an input called ID, an input called code that is of type ID, and is querying for an object called trip, and you pass that ID in, and then you're asking for the name. And this syntax is again special syntax for interfaces in GraphQL that just says, if the returned object on the server side matches pax trip, do something specific, or if it matches driver trip, do something very specific. So yeah, this interface is basically saying you have the flexibility to choose to return certain details if it was a passenger object versus a driver object, agnostic of what the input code is. So you're basically taking advantage of the type system to kind of like abstract your code away. Like let's say you didn't have this luxury of this nice type system. What you would end up doing is you would say like get trip, and then you would have to go inside the trip object and then check for stuff like, right, like maybe there is a field that's called is passenger trip, or that's a little bit verbose, but you would have to do some sort of a hack like that to figure out that, oh, this is this input, so this branch of code can only execute if this condition is satisfied. So yeah, from a business model perspective, this makes a lot of sense to have interfaces, and it basically cleans up your code. And union types is, so I think Go has union types, but in general, like the actual support for the union type programming concept is a little different across languages. GraphQL seems to have like the actual support for it, which just says, if you detail your business as, let's say, Lyft platform user, you can write it out as a union and say, okay, a platform user on Lyft can be either a customer or a driver or a courier. So this is slightly different from what was being done here. So interfaces here rely solely on the type information. to kind of like say that, okay, if this was a type, do something slightly different. Union types kind of solidified this notion that if you had an object, it can only be of this or that type. And when you try to apply this Lyft platform user, your type checker will check for you and then say, like you missed implementing driver. So I guess you guys also work with TypeScript, and I think TypeScript has that support. So the syntax is again a little bit weird, but I think you can make more or less understand what's happening. So if you had a query called get details and then it accepts a code or an ID as input, you're requesting from GraphQL a trip object that says, depending on the return type, if it's a customer, do something. If it's a driver, do something. If it's a courier, do something. You could kind of get the same output here using interfaces. Like you can kind of mimic what's happening with the specific union type feature, but like interfaces they have one missing feature, which is that your type checker won't tell you if you missed a case. So for example, over here, let's say you forgot to write on courier, I think GraphQL will complain, but for interfaces, it probably won't. And it'll fail silently at runtime. Okay, and then before we look at some code and look at some demo, there's also this concept of input types, which just says, like if you want to define a API, this is the input for that object. Sorry, this is the input object for that API, and this is like the specific syntax. It just says input of with the name and then the actual attributes or the fields. Okay, so before we jump into query execution, I quickly wanted to go to the playground to show you. So I have a bunch of pre-prepared queries. I wanted to show you like how this works and just like go over what's happening so that the ideas stick. So before that, I just wanted to pause very quickly and ask if there were any questions right now. I guess I don't see anything on the chat as well. If we don't have any questions, I can just move forward. Okay. So you guys can see this playground. So this is a very popular playground. Like I found it the first time I was trying to learn about GraphQL, and I thought this was a good experience to look at and learn from like just from a no setup perspective. So okay, so let's go over what's happening here. So this view that you're seeing is the GraphQL playground. So when you build a server, there is an option to turn on this view that lets you basically construct queries on the fly. Assuming you have your server implementation done, you could just query all these things and just check that things are working. So let me quickly go over. Give me 1 second. Okay, so let me quickly go over what the data set looks like. So here in this example of like a JSON response, the data that we're going to work with is continents and countries, very similar to what we discussed before. So you have at the top level a list of continents with a code that identifies them and then a name. So the schema here is that you have continents. This is a JSON object. You have continents, code, name. Then you have a second dictionary for countries, which is also another dictionary that maps from country code. So for example, here it'd be AE for the UAE or US, etc. That maps to a list of attributes. And so we have continents, countries at the top level, and then you have at the top level languages, which is basically another map of language code to some specific information. So name, the native, basically the representation, and R2L. So RTL just basically means right to left, like do you write from right to left or left right? And then there's a list of it. So this is the data that we have working on a running GraphQL server. and I'll link it. And I guess I can send this link out. So basically, this country's GraphQL repo has all the data that we're going to look at. And this specific repo by Trevor Blades has a live GraphQL server that we're going to interact with. That is feeding off of the data that we just looked at. Okay, so I have named these queries very creatively, like 0, 1, and 2. Doesn't really matter what the names are, but yeah, I guess we can just jump in and get started. So let's say, given our countries and continents database, you wanted to get data for a specific continent, let's say just North America, right? So if I were to, so this query is already set up, and if I were to run it, you would get back this output. So basically what's happening is when you write your client-side code, you would end up constructing a string like this. I'll show you in a second how to pass in inputs, but assuming there's a hard-coded input that you're just testing, if you wanted to get very specific data, you would just say, query, a potential query name. You can also just not have it and have it as an anonymous query. That also works. But yeah, a named query here called 0 that is asking for the continent object. And on the back end, somebody has actually implemented this filter that says, if you pass in a code, I will give you very specifically the continent that you care about. So let's say, let me expand this a little bit. So let's say you, let's go back here. Okay. So continent has a type with the capital C continent, code, name, and countries. And code is like we saw on the slides. It's an ID, a string, and the countries is a list of countries. So what's happening over here, and let me just close this. So the docs is generated automatically because the server implementation and the client implementation is reading off of a definition, right? So there is a file that I'll show you next that has all of these types defined, and basically the playground is just reading off of that and knows what's happening. And this playground is super powerful in that it can autocomplete stuff based off of the information it has. So here what's happening is I'm just saying, give me the continent that has an input called NA for North America, and then give me the names. I can also do something like, so based on what I just saw here in the docs, the data model is code, name, and countries, right? So let's say I wanted to know all the countries in this continent. So I can just go to countries, and this is the autocomplete from the powerful playground. So if I did that and I hit run for query 0. Okay, so we see the first error based on what we know so far about data models. So here what's happening is the countries object is a list of countries. So what GraphQL also tells you is that even though you are asking me for countries, and you probably wanted all the fields from the countries object, and let's say I go look at country, right? So country has all of these fields: code, name, native, phone, continent, etc., etc. So what GraphQL is complaining about here is that I don't return all of the data that you care about. If you want all of the data, be very specific and list all of them. So that's what this error means. So let's say I just wanted name and countries, like this second query. So I won't go ahead and change this too much. So let's say I look at query number 1, right? So query number 1 says continent with the name and the code, and give me all the countries and their names. So this query will run. And if you see over here, you basically got back a data object that is also of JSON format that says, here's the continent with the name. So if you looked at this query's shape, which is continent, name, code, countries, name, you get back the same thing: continent, name, code, countries, and then a list of names. Hopefully that made some sense to you. Like basically whatever you're asking for in this query, you get back exactly that shape. with the respective data. So now let's say, I wanted to get, let me show you one cool thing. So countries, the data object is code name, all these fields, and it also has a continent in it. So let me first query. Let's go query country first. Okay. So let's say I just wanted to get information about a country. So let's say I did this query. So query number 2, which is give me country with input of code called US. Give me the capital and the currency. So if I were to run number 2, I would get back this data object. As expected, it's a country, capital, country, currency, and on this side, you have country, capital, currency. So a funny thing happens over here because your data model is kind of like recursive. So basically what the data model we are using is a continent is composed of countries, which you saw with the list of countries, but a country can also have a back reference to a continent through a continent object. So you can do some funny stuff like this where you can ask for, so look at query 1.1. So you can ask for, give me the continent with the code NA, give me its name, its code, the countries in it, and for the countries in it, give me the name, the continent, and the name again. So this actually will run and give you this very interesting recursive output. I wanted to show this example because this will help solidify and make you very familiar with how resolvers work on the server side. So basically, the server doesn't actually care that you did something silly like this. It just cares about the fact that, oh, this query compiles. So you can actually do. So I have this highlighted out as a comment. So look at query 1.2. So it's similar. It's more or less the same thing as query 1.1, except at the second level of asking for continents, I'm asking for countries again. And I hope you see the funny part here that you basically created a recursive structure in your graph, and like GraphQL is okay with giving you that data, except it'll just take a long time and it'll probably just, it took a while for it to show up, but basically, at the top level, you ask for the details for North America, and then you ask for the list of countries, and then within those list of countries, you ask again, give me back the the list of countries within the continent. So you could go through all these levels of nesting, and it'll be fine. GraphQL will just work because of the way resolvers work on the backend. So I guess let me show you one more quick thing before we go and talk about the backend implementation. So one common thing that will happen, so in your front-end view, let's say you're building, I think the project that you're working on, some sort of like a friend post user sort of thing. So let's say you wanted to get exactly 2 posts for a user, you would do something similar to this. So basically this query just says, give me the country of code US and give me the country of code CA for Canada, and give me these 3 fields from those countries: name, capital, and currency. So the cool thing here is that if you do not write this prefix of C1 and this prefix of C2, like without them, GraphQL will just fail and it'll complain that you can't do this. If it returns in time. Yeah, so here it just fails because countries conflict because they have differing arguments, use different aliases. So I guess the thing to highlight here is that when you write a query and you're asking for country, you are basically saying give me that one object because you also specified this, this input of US. So if you fix that with the aliases, you would get the right output. So here you have like 2 data points, C1 and C2. You can name this whatever you want when you write your front-end code, and then you can retrieve 2 sets of data for the same shape. And I guess the other cool thing to note here is how do you refactor this? So if you end up doing something like this where you want to get the same fields for just 2 different inputs, with GraphQL, you have something called fragments. So the fragment syntax is also very similar to the query, the types, and the mutation that I'll cover next. But yeah, here you say fragment, you give it a name. It's called simple country info as opposed to verbose. And then you say this fragment is related to the object called country. And this previous query that repeated this information about name, capital, and currency now gets encapsulated into one small block. And this query gets rewritten into this part right here, which with the triple dot syntax. So this syntax just says, I think this is very similar to JavaScript, right? So this one just says expand the fragment called simple country info, and then it basically just does a replace when it runs a query, and it will basically run this query. And the other cool thing in queries is you have good control flow. So for example, I just use the fragment query above, and I've just basically said, you can use these two inputs and these two include and skip directive that basically says, if you pass in a Boolean, it'll evaluate it at runtime, and it will, either include the field for a return response, or it'll skip that field. So in this example, if I run query 24, which has the filter on, I'm just calling it filter, it's not exactly a filter, it will ignore the fields. So let's run 24. And in both, so if you looked at this line here, it just says include capital if false. Obviously, you can pass an input. I'll show you that next. But I've hard coded a Boolean here. So here it just says if false, which will result in false. So this field gets thrown out. And for skip, if true, this field gets thrown out. So you get back just the name field. And I guess the most important thing here for client-side code is trying to understand how to do inputs. So yeah, we briefly looked at this syntax on one of the slides. But basically, if you put a dollar in front of a keyword or a word, that'll be treated as a placeholder. So in this view, we can pass in query variables using this like little box, and I'll show you how to do it in JavaScript, which is a little bit different. But yeah, so here in this query variables portion, I have a country filter that I take as input. So this code is very specific to the client side, to the server side implementation that I'll show you. But this is how you pass in an input. So you basically set it up with this dollar field, and then very similar to how, over here. So very similar to how you pass in code CA, you would pass in like code into the continent or the country filter into countries. The rest of it doesn't change. It's just that this specific syntax, so this keyword has to match with this keyword, or rather this symbol has to match with the symbol, and then you can inject values, and at runtime, your query would evaluate to something different. Okay, so yeah, I guess I can just quickly run one of these and just show you what this does. So if I run 3, code over here is AS, which is for Asia. So this query just says, get me all the continent data for like name, and the countries within Asia. So we can come back to this in a quick second, but for now, yeah, I think this should cover most of the important features of the client-side work. And I guess let's go talk about how the server does stuff. So in all of the slides that we saw and in the demo that we saw so far, we basically just looked at the code assuming that the server is implemented, but we never talked about what the server actually does. So the query language is defining the data. So it just says, this is data, this is the relationship, that's about it. The actual execution happens on the server side. And there is code that more or less mirrors the definitions that you provide. So if you define a type called country, there will be a couple of equivalent things or equivalent code, symbols code on the other side that has to map one-to-one. And that's how GraphQL will figure out that, oh, if somebody's asking for countries, this little bit of code here that relates to countries is how things line up. So I guess like one quick sort of like an abstract thought is, how does GraphQL know what to do when you ask it to execute like a complex query like this? So if I were to go back here and let's have a look at this query, right? So this query just says query. So the query 0 says, get me all the continents with the code NA and name. So this one, like if I had to guess what the server would do, it's kind of easy to guess. You could maybe say something like, on the server side, you would like go talk to a database and then pass in this input called code that somehow GraphQL magically gives it to you, right? Like, so on the server side, somehow magically gives it to you, and then you call the database, get the output, and then you send a response back. So that kind of makes sense. But what about these guys, right? Like these, this part is similar to this in the second query, in query 1. But the countries part is a little bit non-obvious because here you're saying, give me the continents, give me the names and the code. That's fine. But then also give me the countries associated with it and the name of the country. So like this part is a little bit unclear how we actually will do the execution. And again, this is the like how this all works on the backend is kind of like the innovation for GraphQL. And like I said in point 3 here, the idea is a graph. So when I said think about a program as like graph execution, that's kind of similar to what's happening over here. So here, like this in this query syntax, it's not obvious what's happening, but basically what you're trying to say is get the name, get me the countries, and then execute a second sort of like a recursive query that also gets the country information, if that makes sense. If there was a question, like I can just pause for a second. But yeah, this point is like a little bit interesting and important to understand. Because the whole, like, this is the crux of GraphQL. When you give GraphQL this query, it understands that there is a recursive structure here because it can compute a graph. So it can compute a graph like EU to Europe to countries to France and Germany. And when it executes stuff, it'll execute the top level, then figure out that, oh, there's a second level to things, and then execute. So as you keep nesting stuff in your query, each of those gets executed in a kind of a tag that starts from the top and then keeps going down and then eventually comes back. It's basically like a recursion that follows that graph structure. Yeah, I just wanted to pause for a second here if there were any questions. Okay, if not, I think we can just go ahead with the server side code, and yeah, that should be it for us. So yeah, so just to reiterate the point, each field is a declaration of what to get, not how to get it, and the server will handle the how part. So when we ask for continent EU, the server understands that, okay, go get the continent, and the server will match continent to continent, and then it'll say, okay, the user has said if they ever want continent, go execute this like backend query and get that output. And then the matching is done using the concept of resolvers, and I'll show you in code how that's done. Yeah, like I was saying with the graph, in this specific syntax, if you write out query over here, it says that there is a resolver for query that if a user asks for human, go get it from the database and then massage the output and then give the output back. So that's all I had in terms of slides. So I'll just quickly go over some of the server side code to get a sense of what's happening. Okay, so this playground is based off of just this one single index.js file that has all of the GraphQL stuff. So okay, so in terms of getting started on the backend side, let's look at the server code. So you create an Apollo. So I think you guys are using Apollo. So this example would be very similar to what you would do. I guess you might be writing in Go, but the interfaces are kind of similar. Like you will be writing similar code. Here in the JavaScript, like here for const server, what we're doing is we're just saying, like starting things up, and we pass in this object called typedefs and resolvers. These you can ignore for a second, but the typedefs and the resolvers are the key points. So let's go look at typedefs. Okay, so this is very specific, I guess, GraphQL JavaScript syntax that just says whatever follows GQL is like graph query language definitions. So all of the stuff that we saw in the previous slides is basically here. So continent is defined as a type. It has code, name, and countries in it. Countries is a list and it's non-null. For type country, you have a list of fields. So code, name, native, phone, a continent that references back to the continent that the country is part of. A couple of things around capital currency and language. Language is another data structure or a type that is defined at the bottom, and we'll look at that in a second. And states is a list of state types. So state over here is defined as just the code for the state, the name, and then the country it's associated to. I hope, like, just by looking at these three things and the fact that you have this country and this country match up, this state and this state match up, continent and continent match up, you kind of see like a relationship going on in terms of like how the objects are set up. And language is the same as this guy here. So language is code, name, the native script, and then RTL. Okay, so these are the objects that your business model is going to work on. So these are like the high level ideas. And then you have inputs. So maybe we can first look at the types, the queries before we look at the inputs. So the inputs are always associated with the queries or the mutations. For this, like for this example, we just have like queries. Mutations are very similar. It's just that the keyword is a little different, and the action or the output is a little bit different. So for queries, what happens is you have these are the things that you define now. So the types will line up with what the front end wants and what the backend has, and the query is the thing that will help bridge the two. So all of the stuff that I told you about with like recursion and graphs, all of that happens right here with this bit of code right here. So let's look at, let's say, continents, right? Or maybe let's start with continent and then go to continents. So line number 65, continent is basically saying a query exists on the backend of name continent. So this name has to match up with this one here. That's how GraphQL knows that the two are the same, because you see query here and continent here, and then on this side you would see query and continent. So to GraphQL, you define a query called continent that takes an input called code, and then it returns an output called continent object. So this continent and this type here are the same thing. So let's say this was the only query you had, and that will make it easier for discussion. How would you actually implement the code? So this bit of GQL right here just says to GraphQL that, okay, this is what exists, but we haven't implemented it. So to actually look at the implementation, we are looking at some JavaScript code. Like if there are any questions about this, yeah, let me know. But all of the action happens in this resolvers map. So okay, so let me quickly go back here. So here we have resolvers. So to the GraphQL server, you're saying look at this object map, and this object map will tell you how to deal with the types and what to do with them, right? So let's say you wanted to look at that query, which was continents. What ends up happening is GraphQL, when it gets the request in, there's a bunch of magic that we don't really have to worry about. That's the framework work that will go from this part. When you hit play, it eventually comes to resolvers, and within resolvers, it will go into query, because query and query, that's how the connection is made. And it will look into continent. So this is the map. Query is a map, and it'll just map those two keywords, continent and continent, and then it'll say, and then it does the massaging of, like preparing it in the format such that it can execute this code. So basically, what's happening here is, this is JavaScript, and here for GraphQL in Go or any other language, you have to take in two inputs. There's four inputs, but only two are shown here because the other two you can ignore for a second. One is the parent, and the other one is the actual inputs. So whatever you pass in here, this code, this guy has to match up with this guy right here. So what the query does is this bit of JavaScript, and then it returns the output. So here it says, like, go look up this continents object. For like a project or for production, you would instead like maybe call, like an actual database, right? So over here, this project is just mocking some data. So again, like GraphQL is agnostic to the database or the backing store. So in this example here, you're looking at continents, and this is coming in from like a JavaScript object that is read when the server starts. Easily, you could have just said, like remote DynamoDB database.get, something like that. So yeah, by convention, if you put in a method into this query map called continent and then takes in a code as input, GraphQL will just work. Very specifically, what this implementation does is it says, okay, go look up the continent using like, a regular map, get the name, and then, if the name exists, return the name and the code. So basically, let me go back and execute 0. So what happened here is query got matched to query here. Continent gets routed to this continent, this guy. And then the code that you pass in has to map back to this. And on the back end, you as a developer basically said, okay, just go look up this map, give me the output. And you said return code and name. So code and name is something that gets returned. However, because you asked only like on this query, I've asked only for name, code doesn't show up. But if I were to do code, that would work too. Takes a second, but yeah, here we go. So code. So from here, how do we think about, let's say, this particular query, right? So the second query that I showed you did continent, name, code, and then it also asks for countries. So how does the countries show up? Again, through the GraphQL resolvers map, what happens is, so here we are asking for continent. So the resolver shows up, it goes to continent, it does all this, right? Same as before, it executes it, it gets the code that you cared about, and then it looks at countries. And in the query portion, we don't have countries, and that is for a specific reason. Over here, like GraphQL has this concept called a root, and in this case, the root is called continent. So once you get past continent to like any of the fields below it, you just like GraphQL basically then goes and looks at these maps in the resolver. So what happens here, and this is the cool part about GraphQL. So here, like when you execute continent, you get back the continent object, and then GraphQL matches countries to country over here. And then it says, here's all the bits of code that you need to populate the country's object. And then when it's doing this, you have access to the continents object. So as you're executing the graph, like from top to bottom, you'll execute the top portion, prepare all of that data, and then pass it along to the recursive call. So GraphQL, when it gets to the recursion, it will understand that, oh, there is something called continents. So all of this, so for example, continent here has to map back to what was sent above, if that made sense. And it's the same thing for capital too, right? So if you go back to your business model or the object model, you notice here that country has a currency, and this is like a scalar type, right? Meaning it's a string. It doesn't have to do too much beside for example, continent has country, which is not a scalar type. So what happens here is that currency is understood as being tied to country, and that's it. So from a graph perspective, you would have country and currency, and GraphQL understands that, oh, if I ever see currency, I have to first find country, and then I can go and execute that bit of code. So yeah, I think just before we wrap up, basically what's happening here is that you write your resolvers that will map back to the queries that you care about, and you pass in certain inputs such that you can work with them, and GraphQL will understand in which order to execute. As long as you give it all of the necessary executors, it'll just work on its own. Yeah, I guess that's all I had here. Yeah, I guess for an intro GraphQL tutorial, this was a little bit too much to take in. So if there's any questions, happy to answer. Otherwise, I'm going to stop here and stop sharing my screen. Yeah, I guess I'm sort of done with the presentation. Thanks for coming. If there are any questions, happy to answer them. Otherwise, I guess I'm not sure. I think we can just end the call.
Thank you so much, Sarma. That was really helpful, very informative.
Awesome. Thank you.
Thank you so much.
All right. Yeah, take it easy. Bye.
Have a good day. Bye.